the interconversion of energy and matter. One of the most profound discoveries in modern physics is encapsulated in Einstein's famous equation E=mc², which reveals the interchangeable nature of energy and matter. This mass-energy equivalence suggests that when sufficiently concentrated, energy can give rise to mass, and mass can be converted into energy under the right conditions. This realization has led to groundbreaking scientific advances, including nuclear reactions and particle accelerators, which profoundly explore the transformation of energy and matter. In its various forms, energy can transform into different types: light into heat, sound into mechanical work, or chemical energy. A prime example of this transformation occurs in photosynthesis, where photons, the carriers of light, are absorbed by plants and used to convert carbon dioxide and water into glucose. This process illustrates the conversion of light energy into chemical energy, which can further be considered a form of matter. Every entity in the universe can be understood as a cumulative form characterized by the amount of matter plus energy it possesses. Some entities are abundant in energy, while others are comparatively energy poor. For instance, the sun is densely packed with energy, continuously emitting light and heat, but it will eventually exhaust its energy and collapse into a dead star. On a more familiar scale, while containing significant energy within its molecular bonds, a glucose molecule can release that energy when the bonds break, resulting in carbon dioxide and water, both low-energy products. When detached from a source, each packet of energy could, in theory, travel infinitely, undergoing continuous transformations. However, something remarkable happens if a photon's energy is confined to a small space region. In my view, the energy wave begins to loop back upon itself in a wave-like self-referential motion, which ultimately catalyzes the creation of mass, like a snake chasing its own tail within the confines of an imaginary sphere. This suggests that mass arises as a byproduct of confined energy, where the energy's motion within a defined space field gives rise to particles, the fundamental units of matter. What does it take for a packet of energy to be thrown off its linear course and take a spheroidal course? Extreme gravity? Excess energy? In a fundamental sense, matter can be thought of as a spatially stable or confined field within which an energy packet exists. Although the energy within this field is constantly in motion, it is confined to a small, fixed space. This field can be thought of as the smallest particle, a fundamental particle, whose nature is determined by the specific energy content and the patterns of motion within that field. The different types of primitive particles that emerge depend on the energy's magnitude, motion, and confinement. Entities that are capable of existing will persist, while those unable to maintain stability will perish. The yin-yang of energy and space creates matter that has mass and gravity. Based on these philosophical assumptions, energy exists in three distinct forms: free energy, transition state energy matter, and absolute matter. Free energy, exemplified by light or electromagnetic radiation, represents the most dynamic form of energy, which keeps traversing space unless obstructed. Transition energy matter, on the other hand, is exemplified by high-energy molecules like ATP. This form represents a transient state where energy is temporarily bound to matter and can be released. Finally, absolute matter, consisting of atomic particles such as protons, neutrons, and electrons, is characterized by low energy and high stability. The structure of these particles is held together by fundamental forces such as gravity and the strong and weak nuclear forces, ensuring a state of equilibrium. This classification of energy and matter highlights a progression from dynamic, unstable forms toward more stable states. At its core, the universe revolves around the intricate relationship between energy and matter, their constant interchange shaping the fabric of reality. The transformation of energy into matter marks the birth of stable structures, from subatomic particles to entire galaxies. Conversely, the conversion of matter back into energy can unleash vast amounts of energy, as demonstrated in processes like nuclear fission and fusion. This continuous exchange between energy and matter is the universe's engine, fueling the processes that govern the microcosm and macrocosm.